Welcome to the Hazmat Files podcast, where we bring you industry insights and real-world perspectives to support emergency responders and community safety. I'm your host, Erica Fisher. During hazardous material incidents, air monitoring is one of the most important tools available to responders. But collecting readings is only the first step. The real challenge is understanding what those readings mean and how they influence critical decisions such as planning, evacuation, sheltering in place, responder safety, and incident stabilization. Today, we're discussing how air monitoring data is transformed into actionable information and how the Emergency Response Planning Guides, or ERPG values, help responders assess risk and make informed decisions. Before we begin, a quick disclaimer. The views and opinions expressed in this podcast are those of the hosts and guests and do not necessarily reflect the opinions of TransCare or its sponsoring organizations. The content provided is for informational purposes only and should not be construed as legal or professional advice. To help us unpack what responders and industry need to know, we're joined by two guests who bring considerable knowledge and expertise in ERPG values, air monitoring, and incident response. Michele and Chris, welcome to the podcast. I want to take a moment for you to each introduce yourselves and give our listeners a bit of your background and experience.
Hi, I'm Michele Twilley. I am the Chief Science Officer for the American Industrial Hygiene Association, and I manage the Emergency Response Planning Guideline Working Group, as well as other activities within the association. And I come to this with 38 years as a practicing industrial hygienist and an early career in emergency response.
Hey, good afternoon. I'm Chris Kuhlman. I'm Vice President of Emergency Response for Onterris, and I'm a board-certified toxicologist and certified industrial hygienist. I've spent nearly 2 decades supporting hazardous materials incidents, industrial accidents, transportation emergencies, fires, chemical releases, and natural disasters. Currently, I'm Vice Chair of the AIHA Emergency Response Planning Guideline Committee, or ERPGs, which develops the values we're going to discuss today that are used worldwide to support emergency planning and response. And largely my focus in my occupation is helping responders and decision makers understand chemical hazards and use air monitoring data to support decisions to protect workers and communities.
Thank you both for joining us today. Many of our listeners have likely heard the term ERPG values, but they may not fully understand how to apply these values in both preparedness activities and during incident response. Michele, can you explain what ERPG values are and why they are important during emergency response and planning?
Certainly. So ERPGs are 1-hour exposure levels that are developed by AIHA to assist emergency response personnel in planning for accidental or intentional catastrophic chemical releases to a community. They are developed to meet the need for community emergency exposure planning guidelines, particularly for chemicals that have high potential for uncontrolled releases and those that might pose particular hazards because of their volatility and toxicity. The primary focus of an ERPG is to provide guideline levels for once-in-a-lifetime, short-term, and by that we mean typically 1 hour, exposures to airborne concentrations of acutely toxic, high-priority chemicals. For every chemical, there are ERPG values associated with mild, serious, or severe risks. ERPGs are also important for compliance with the U.S. EPA's Emergency Planning and Community Right to Know Act, or EPCRA.
That's a great foundation. Now let's connect science with the operational side of response. How do ERPG values help guide protective action decisions?
ERPGs are just one tool in evaluating how community exposures should be controlled. So it's not a bright line. You don't just go to the ERPG book and say, well, this exposure is greater than the number and we've got to evacuate. It's really more nuanced than that. Like I said, one tool in the toolbox. Much of the use of ERPGs is already factored into the North American Emergency Response Guidebook. That's that table 1 in the green section of the book that provides initial isolation and protective action distances. Another way to use the ERPGs is by modeling what could happen in the event of an industrial or transportation incident. And we plug in the ERPG values into those models. They can be used with information such as the inventory or the storage volumes of a tank, the atmospheric conditions. We can use these to provide computerized estimates of the potential spread of the contaminant and airborne concentrations in the case of a release. From these estimates, then we can come up with an action plan. And those plans may vary depending on what else is around that release or in the pathway of the plume. Those considerations will be based on things like population density, the type of population. Are we looking at schools or a hospital? What kind of terrain is involved? Are we in mountainous conditions or very flat land? What the weather conditions are and the nature of the release. So using estimated release rates and the physical and chemical properties of the products being released, along with meteorological data and dispersion modeling methods, we can generate the estimated distances and the time of arrival for ERPG concentrations. This can be used when making determinations to evacuate, shelter in place, or just continue business as usual.
And Michele, I'll add to that too. The way I view ERPG values, they're really one piece of a decision-making process when you're responding to an emergency. Like Michele was saying, I use them alongside other things like air monitoring, modeling, looking at weather data, incident conditions, and population characteristics. Michele mentioned the ERG guidebook, the Emergency Response Guidebook. That uses an ERPG value as an important benchmark to evaluate when evacuations may need to occur. I also look at the ERPG 1 levels as a level where people might start experiencing symptoms like irritation in the community. So between those two values, the ERPG 1 for irritation and an ERPG 2, which might be a level someone could experience some more serious health effects, those are the concentration ranges we're looking at when we're trying to make those decisions to support a shelter in place or evacuation.
Before we move even further into ERPGs and how they're used in the field, it's important to address some of the misunderstandings that can lead to misinterpretation. What are some common misconceptions about ERPG values that responders should avoid?
I'll start with this in that ERPGs are not regulatory limits or bright lines. They are intentionally neither too restrictive nor are they too lax. So they're the best estimate of the potential for exposure to a community or a vulnerable population that we can make without being too stringent or too lax. There are 3 ERPG values. ERPG 1 values are based on either objectionable odor or mild irritation. I think one of the misconceptions is that ERPG 1 is solely based on a health endpoint. And emergency responders need to know that it could be based on an objectionable odor. ERPG2 values are based on reversible symptoms or serious health effects that could impair an individual's ability to take protective action. So somebody should still be able to get to safety even at these ERPG2 concentrations. And then ERPG3 values are concentrations that people can be exposed to for up to 1 hour without developing life-threatening health effects. And I think all too often people think that that's the value associated with life-threatening health effects. Now, granted, some vulnerable populations could experience a life-threatening event, but care is taken by the committee to make sure that these life-threatening conditions aren't prevailing. In any case, if a lower explosive limit is lower than a health-related concentration, then the LEL is the concentration that is driving the ERPG 1, 2, or 3 value. First responders really need to understand the ERPG value to know how it is applied. Each ERPG has a technical document that you can read and understand how the numbers were calculated and what they are based on.
I'll just add to that, because you mentioned it, Michele, about the misconception about the ERPG-1 sometimes being based on odors versus potential short-term irritative health effects, for example. There are other emergency exposure guideline values that have just at a first appearance, similar definitions as the ERPGs. And that is something that makes the ERPGs unique, and that ERPG 1 level could be based on an objectionable odor. And this has actually come up in real life emergency responses where there was a release of a chemical that had a very strong objectionable odor. And people in the community where we were doing air monitoring were detecting that. And when we did air monitoring and we saw some readings that were above that ERPG 1 value, the other agencies and health agencies that were out there thought that that was a level that community members might experience a health effect. However, when you looked at that ERPG value, it was actually based on an objectionable odor. And odor is actually pretty important for emergency response, although it might not be a level where you experience a health effect. When you have an objectionable odor, it does tell responders that the public may become aware of their release and potentially alarmed before adverse effects are expected to occur. So in other words, people can smell something long before it's present at a concentration that could be expected to cause irritation or other health effects. And understanding that distinction helps emergency teams anticipate and manage community impacts and not just health impacts, right?
The absence of odor is not always a good indicator. Keep in mind that there are a number of people that have no sense of smell. They can't detect the odor, or you might become fatigued over time. So that ability to sense that odor is diminished. Those are two key points to consider. And also, you might be expecting an odor to exist where it really doesn't. And you can point to the Loudoun County incident where an underground storage tank containing propane had been leaking, and the soil itself scrubbed the ethyl mercaptan odor from inside of the residence where the propane had been accumulating and ultimately exploded. Odor is a very tricky element to evaluate in emergency response.
Great points. And air monitoring provides a lot of data, and ERPG values can help put that data into context. But ultimately, incident commanders still need actionable recommendations to help them protect their team and the public. Chris, from your perspective, what role does air monitoring play during the first operational period of our hazardous materials incident?
That's a great question. So the first operational period is often characterized by incomplete information. Some dispatch reports may be inaccurate. The information about the chemical release may be limited. Witness accounts may conflict with one another, and incident conditions can be changing rapidly. Air monitoring can provide responders and the community with objective data that helps transform those assumptions into informed decisions. Air monitoring really helps us answer a number of questions. It can help us understand what the actual hazard is and who may be at risk right in that moment. Because again, we're talking about air monitoring. We're talking about understanding what that chemical concentration is right in that moment in real time versus, say, air sampling, where you take a sample and send it to a lab. During the first few hours of an incident, responders are typically trying to understand things like what was released, is it airborne, where is it going, how far has it traveled, are the first responders at risk, and then is the public at risk? And based on all those questions, can air monitoring tell us if protective actions are necessary?
And I'd like to add to that, this is when you are doing most of your survey work. You're trying to identify the chemical agent of concern and at what concentration and where it might be traveling. You might be using some direct reading instruments to scan the environment and look for concentrations that are potentially alarming or indicate a leak. There's other types of air monitoring that would be used for assessing exposures. And this takes skill in determining where and for how long to deploy air monitoring equipment. And it depends on the question you're trying to answer. So this is where industrial hygienists come in handy.
And I'll just say too, Michele, you mentioned the emergency response guidebook before. Oftentimes when my team arrives to a site, it's likely that the local responders, like a fire department, based on what their knowledge was of the chemical that was released, they might have referenced something like the emergency response guidebook and established either a shelter in place or an evacuation. So what real-time air monitoring can do is, once we understand the chemical of concern, we can go out there and in real time evaluate those conditions in this area that maybe has a shelter in place or an evacuation, and use actual data, chemical specific real-time air monitoring data, to determine if that shelter in place or evacuation is appropriate, or in some cases maybe needs to be expanded based on that data.
And that's the perfect segue into knowing where to monitor, what to monitor for, and how to interpret those readings can be a challenge, especially in the early stages of a response. As you guys said, when information can be limited, conditions are changing, and the responders are trying to understand what is occurring and what the next actions need to be. When arriving at an incident, what factors tend to influence your monitoring strategy?
For me, when I get a call that there's been an incident that will require some exposure assessment, either for responders or for community members, the first question my team asks is, what is it? What is the chemical that was released? The next is, where is it? Is there going to be potential for community exposure? Oftentimes these incidents, they can happen anywhere, right? You might have an incident that occurs in a very rural area, or you can have an incident that occurs right next to a densely populated area. So obviously those are different situations that would require a different approach. You need to look at your wind direction, meteorological conditions. If there is a community nearby, is it possible that it could be blowing a hazardous atmosphere towards that community? Next would be the volume that was released. Is there enough volume of a chemical release that could result in a sufficient concentration where we could reasonably anticipate that either responders or community members might be exposed to an elevated concentration?
And Chris, as you mentioned, there are environmental and situational factors that significantly impact what responders will see in the field and how much confidence they can place in those readings. How do weather conditions, terrain, and changing incident conditions affect the reliability of air monitoring results?
Changing conditions can affect where you would want to do your air monitoring and also the severity of some of those readings, right? So the factors that you need to consider that would influence your monitoring strategy would be the source of the leak. Are we talking about a tank that's leaking at an industrial facility? Is there a fire and a large smoke plume that could be blowing over large distances? Was this a transportation release? But when we boil it down to the chemicals, even just chemical properties can affect your monitoring strategy. You need to think of things like vapor density. Is this a chemical that's going to be heavier than air and might accumulate closer to the ground in storm drains and culverts, things like that? Is it a volatile compound? If it's a very volatile chemical that was spilled, you would expect there to be the potential for elevated concentrations near that incident site. Does the chemical react? Oftentimes we're presented with a chemical, but there could be other materials present that could react with that chemical and form other chemicals that you'd also want to be conducting air monitoring for. The other thing is just the nature of the chemical. How toxic is this chemical? Is it something that can cause irritation at very low levels? Is it something that presents a risk for short-term exposures versus long-term exposures? These are important factors to consider. And then we've already discussed how important understanding the meteorological conditions of an incident are. What is the wind direction? What is the wind speed? How often is that going to be shifting? Typically, when we go out there to collect air monitoring data, we are looking at those downwind locations where you'd expect vapors to migrate. But I think it's also important to collect data really in a 360-degree radius around an incident site to just characterize concentrations in those sensitive areas where there might be schools or other things like that. Obviously, again, you're going to want to consider sensitive receptors in your area. So factors that would influence that monitoring strategy would be what's around there. Are there schools? Are there hospitals? Are there neighborhoods? And then also, again, are there going to be workers and other responders coming to remediate this incident? That's going to be a given, in addition to the firefighters, police department, and other agencies that are going to be supporting the response efforts too. So really, the operational objectives that are going to be influencing your monitoring strategy are protection of the public, protection of the workers and responders responding to that incident, and then also evaluating the source as that's trying to be controlled.
And I'll add, from the technical side of doing this monitoring, instruments are finicky. So extreme cold and high humidity can cause interference with the readings that you're getting. If you're using direct reading instruments, if you're using conventional filter or tube and pump, it also has effects on the ability to collect your samples. Cold affects batteries and liquid crystal displays, could prevent you from using the monitoring equipment that you want to use. Humidity can fog lamps and a photoionization detector, or water vapor can be counted as particulate matter. So everything has a use and a limitation, and you have to be able to respond accordingly.
And a classic example of that, Michele, is instruments that are used to measure carbon monoxide, for example. They have cross sensitivities. Sometimes some people installed hydrogen-powered equipment at a facility, and hydrogen has a cross sensitivity with carbon monoxide. So someone taking a carbon monoxide reading might think there's carbon monoxide there when it's actually hydrogen, for example. So that's a great point, Michele.
So once responders have collected data in the field, the next challenge becomes understanding what those readings mean and how they should influence response decisions. What are some of the most common mistakes you see when collecting or interpreting air monitoring data?
Looking at an instrument and getting a zero reading and interpreting that result as zero. If you're using the wrong detection equipment, you could have a false sense of security that there is no hazard when in fact there is. The equipment user has to understand the limitations of that monitoring equipment. The concentration you record when you're using a photoionization detector, for example, needs to be corrected by multiplying the appropriate correction factor for the specific chemical that you're interested in, which could result in an actual concentration that is much higher or lower than what the display is reading out. So you have to be very, very aware of the use and limitation of the equipment that you're using.
That's a great point, Michele, and that's where my head was going as well. When you're developing an air monitoring plan and air monitoring strategy, you absolutely want to ensure that your instruments are capable of detecting the chemical below a relevant exposure guideline. So if we're talking about ERPGs, you would want to have an instrument that's capable of detecting a chemical below, say, that ERPG 1 value. Oftentimes, we're also supporting responders who might be going into the release site, so they have the potential for elevated exposures. In addition to having an instrument that's sensitive enough to detect that chemical, you also want to make sure the upper range of that instrument is appropriate for evaluating those conditions where maybe they have to wear a respirator. Those respirators do have an upper maximum use concentration value. So you want to have an instrument that can evaluate whether those respirators are sufficient as well. And maybe it's so high they need to upgrade to something like a supplied air pack, right?
It all goes back to making sure the monitoring that you're doing is fit for purpose.
One of the critical things to remember about air monitoring is that it's not a one-time activity. As we've mentioned, conditions change, products behave differently than expected, and new information becomes available as the incident unfolds. How does monitoring strategy evolve from initial assessment through stabilization and recovery?
We've talked a lot about looking at meteorological conditions, right? When you're doing air monitoring, say in a community, it's really good to keep an eye on wind direction and shifting. And those types of stability changes could affect your strategy and where you would want to collect data. You also have things like temperature inversions. Oftentimes at night, we've seen temperature inversions occur that drastically change the conditions. And we saw unexpectedly high concentrations during those periods. But really, something I'm looking at is also how the incident changes. You have activities on site. Oftentimes, you have fire suppression. For an example, I responded to a large tank fire where there was active fire suppression going on that also used some vapor suppressing foam. While the fire was active and the smoke plume was very visible, we actually didn't really see anything in the community. But the minute that fire went out, and all of a sudden you had this volatile mixture that was vaporizing, that was quite a significant change. And we did start to see some elevated readings in the community. They were able to address that with some vapor suppressing foam. But again, we anticipated that this might be an issue when the fire was out and had a really good monitoring network out there to evaluate those potential changing conditions once, say, the fire was out.
I think the other aspect of this is you have worker exposures that are occurring to the emergency responders and then to anybody who is coming in to do recovery and remediation. But then you also have your community exposures. So they're very different populations with very different sets of training, skills, and ability to protect themselves. So as the work shifts, you might be going from extremely high concentrations over a short period of time to lower concentrations over a longer period of time. And then also thinking about any residual lifetime risk exposures that could be modeled for what remains after the response occurs.
Those evolving strategies can really come into focus when we take a look at real incidents, where the data collected isn't just informative, but directly drives critical decisions made on the ground. Can you each share a real world example where air monitoring data, ERPG values, or other exposure guidelines directly influenced operational decisions?
We've supported various large chemical releases where communities' concerns centered on, say, benzene exposure. Early air monitoring readings with a photoionization device and some benzene-specific monitoring did help us identify areas that required additional evaluation. But really, those decisions weren't just based on those instruments. We did have to combine it with some benzene-specific monitoring, with some meteorological information, and exposure guidelines such as the ERPGs to determine where those protective actions were warranted and where they were not. And again, trying to understand the difference between an ERPG that is health protective, like Michele said, for a single 1 hour short-term exposure is different than a screening value that might be health protective for 30 to 70 years of exposure. What we're talking about with ERPGs, these are incidents where it's a chemical release incident and there's some reasonable assumption that incident is going to be attempted to be controlled as quickly as possible to limit those exposures. So we're typically looking at 1 to 3 days of exposure. On some of these incidents that we've responded to, those values really helped us understand what the conditions were. And for example, conducting benzene monitoring helped us determine those shelter-in-place actions. When we're talking about things like evacuation in some of these incidents, you also have to understand that evacuation itself presents a pretty significant hazard. It puts a lot of stress on people, especially those in the community. Having to leave your home and possibly involve vehicle travel presents its own hazards. You have to leave medications behind, make sure you've got all that with you. It can present a lot of stress. So really where the ERPGs have helped me on these projects is really understand whether or not those actions need to be taken and use those in the decision making with all those things considered.
And I would add that we could take real-time data that is being reported from the incident and pretty quickly model a potential plume pathway given an ERPG2 value, meteorological conditions, what we know about the source of the release and volume and physical and chemical properties, and develop an understanding of what is in the path of that plume. If you have a plume that's being released over forest stand, it's going to be different than if you have a plume out over the ocean. It's different than you have a plume that is going to hit major highway arteries, hospitals, nursing homes, and other facilities where maybe that decision to shelter in place is the better decision to make. Maybe shutting down the highway, maybe doing some things that you wouldn't have otherwise decided to do if you didn't see the population and the type of that is in the pathway of that plume. You can also look at decay in modeling. So if the spill is complete, how long will it take for the plume to decay to a point where it is either down to an ERPG1 threshold where it's just an odor or irritation issue, or that the source of the hazard is resolved itself?
And Michele, we had another example of what you just said. We responded to an incident where there was a rail car containing styrene. Styrene, as it's transported, needs to contain some inhibitor to prevent it from polymerizing. There was an issue with this particular car that stabilizer appeared to not be working, and they noticed it was actively venting. So there was concerns of explosion, but there was also concern of community exposures to styrene. And we actually were able to quickly develop some models to give us some information on what a worst case release would look like. And based on those models and a comparison to the ERPG values, that did direct us to put a limited shelter in place and an evacuation for members of the community that were nearby, and some road closures, like you mentioned. And as conditions started to stabilize and we were conducting real-time monitoring, all that information together allowed us to comfortably lift those shelter in place and evacuations.
That's great, Chris. And these modeling programs are available for free from the EPA under the Cameo suite. So it's fun to explore the use of them, and you can overlay them with mapping data and census data. So you can see the population that is affected and just major features of the area around the spill zone.
Those examples really highlight why preparedness is key. What would you say are the top 3 things first responders should do to prepare for air monitoring during an incident?
I think the number one thing is to make sure you're working within your skill set, understand the use and limitations of the monitoring equipment. If you don't know how to use it, find somebody who does. That's the biggest part. All too often, even as an experienced industrial hygienist, you get a new piece of equipment that you have to use, and you have to figure out very quickly what those uses and limitations are. Then you always have that challenge of whether or not the data that you're actually seeing is real. You have to rely on your training and your intuition, but also in the calibrations and bump tests and all those things that you're doing in the field to make sure that the equipment is working effectively.
Michele, I'll add, that's perfect. Responders should also just understand how that data will be used for decision making. Really, before an incident occurs, agencies should discuss what types of action levels will they use. We've been talking about ERPGs. Those are certainly things that should be considered. What other exposure guidelines are available? And then again, how will that air monitoring data that they perform support protective action decisions, and who on their team is going to be interpreting those results? And then also, how will that be communicated to the other stakeholders for an incident? If there's an incident command, is there information that can be given to the public? So very often responders do collect a lot of data without really a clear plan on how that data will support those decisions making. So we really just don't want to start with the instrument. We want to start with the decisions you're trying to make.
Exactly, Chris. Purpose-driven air monitoring. So what is the purpose of the air monitoring? What can you monitor for in the air? You can't monitor for everything, and you probably shouldn't. And then compared to what? What are you going to compare the results that you're getting to make that informed decision? And then Chris brought up the biggest part of all of this is how you communicate effectively to the responders, to the community, to the government agencies that are engaged in the response activity.
And effective decision making depends on having both accurate data and understanding how to interpret it. That takes training, practice, and experience before an incident ever occurs. What training opportunities, resources, or other reference materials would you recommend to first responders?
I'll start off with the TransCare training video on ERPGs. That's an outstanding resource for understanding the use and limitations of ERPGs and some modeling. It's a great way to learn more. It's an hour-long course with a little self-assessment at the end, and you can check out the TransCare website for that video. You can look at the AIHA's ERPG app. It's free. It presents all of the ERPG background, use limitations, the table of values, and links to all of the available technical supporting documents for each chemical. You can learn more about modeling from the EPA on their Cameo site. It's a free tool that you can use. So those are the top three that I would go to. Chris, I know you have a good number more.
I would say, Michele, what you just brought up is excellent. I think for the first time, the technical documents for those ERPGs are now publicly available. So if folks do go to the AIHA website and look for those ERPGs, in addition to seeing what those levels are, you can look at some of the basis of those and understand how they were derived and what some of those sensitive health endpoints are. It's a great resource. Makes my life easier too to find those.
As we wrap up, I'd like to leave our listeners with a few practical takeaways they can apply regardless of their role, department size, or level of hazmat experience. If there is one thing you hope every first responder remembers from today's discussion, what would that be?
I think that planning goes a long way. You could look around your community and maybe identify the industrial facilities that pose a risk to the community in the event of a spill or release or a rail incident or a highway incident that you could plan for. And you can model what response you would generate or develop or what air monitoring you would need in the event of a release. I'll give you an example. I lived in a rural area that was undergoing rapid development, and the dairy co-op closed. The hazard there was milk and some disinfection products, and a tobacco flavoring business moved in, and the building was surrounded by rapid residential development and expansion, and it quickly swallowed up all the surrounding farmland. Our local fire departments that would respond to that building had no idea what was going on there regarding hazardous chemicals. And this operation used a tremendous amount of ethanol and methanol in formulating their flavorings. So by engaging the emergency response community in the activities of that flavorings business, they were able to come up with an emergency response plan and do some modeling using the Cameo software and some predictions about what would happen in the event of a spill or release. And that went a long way to giving the local first responders an opportunity to take quick and decisive action to a release from that building.
And I'd like to add something too. So in answer to your question, Erica, good decisions depend on good information, and air monitoring is one of the most powerful tools we have for understanding what's actually happening at an incident rather than what we think might be happening. If there's one thing I'd like responders to remember, it's that air monitoring isn't just about collecting numbers. It's about evaluating potential risk and reducing uncertainty. And really, every monitoring decision should help answer an operational question that improves response safety, the public's protection, and incident management.
Thank you both so much for joining me today and sharing your expertise. Air monitoring and ERPG values are powerful tools, but their value depends on how effectively responders collect, interpret, and apply that information during an incident. For responders, collecting data is only part of the equation. The real value comes from understanding what that information means, recognizing its limitations, and using it to make informed decisions that protect you and your community. To learn more, visit www.hazmatcourses.com to take AIHA Guideline Foundation's online training on their emergency response planning guidelines and their role during incident management. Thank you for listening. Stay safe, stay informed, and join us next time on the Hazmat Files podcast as we continue exploring the challenges and lessons shaping hazmat response.